Hello, my name is Felipe Saavedra. I'm a graduate research assistant at the Civil Engineering Department at the University of Maine. My advisor is Dr. Roberto Lopez Anita, and my research work and thesis is durability of large-scale 3D printed materials. I also work at the ASCC for the TIDC at the University of Maine as well. I'm going to start with an introduction. Additive manufacturing is one of the most common techniques for 3D printed materials, like wood flour PLA and carbon reinforced ABS. Additive manufacturing techniques are very versatile. They're present in a wide range of industries like transportation and construction. Being transportation, one of the most important for my work, since I work for the Transportation Infrastructure Durability Center. The motivation for this work comes from durability of materials used in a 3D printed highway culvert diffuser and formwork for precast concrete walls. These two projects are also part of the TIDC. Well, knowing how durable a material is really important and also can be very beneficial for the industry because it helps the industry to decide which material should I use for the environment that I'm working or the site. So I can know, or I can tell that the material is going to resist during the whole life of the project. Under there's a small figure of how the materials and specimens were obtained. You can look at the lower left. Well, moving to the next point, talking about method. The first was the definition of the standards to be used, the specimen dimensions, and machining for large-scale extrusion-based 3D printed materials. One of the challenging parts of this work was obtaining the specimens because they were not 3D printed directly. They were cut from plates and forms from the two projects previously mentioned. So a plan had to be made and to move forward with obtaining the specimens. Wood flour PLA, carbon fiber reinforced ABS, and wood flour aPLA are the materials used in this study. The difference between the two PLAs is that the wood flour aPLA has some features that kind of solve some issues that the first wood flour PLA has, being the most important one related with shrinkage at the time of printing. Like once the material and the form are printed, they tend to shrinkage. So some dimensions and the materials and the form need to be bigger to compensate this. So it's going to be really interesting for this research work to see how the two PLAs behave. The conditioning selected are moisture exposure and freeze-thaw cycling. The standard selected is D7264 ASTM using 4-point bending to characterize material properties. Digital image correlation, or better known as DSC, and Pontus were selected to measure strains and displacements during the tests. And the durability assessment will be achieved by comparing the conditioned materials with some baseline specimens that they are going to be just maintained at room temperature. Moving to the next point about results and work to come. And this, for moisture conditioning, the 5229 ASTM standard was selected. Wood flour PLA was the first material conditioning. Why this was the first material? It was because it was the only material available at the moment. And the parts for carbon fiber reinforced ABS were not printed yet, so there were no plates to be used. And also the wood flour PLA, it just recently arrived to the center. So in the past few weeks, they've been printing. So that's why wood flour PLA was the first material to be conditioned. According to the ASTM standards, sorption curves are used to define moisture equilibrium content. You look at the figure above, sorption curves are the square root of time versus the average moisture content. For this set of wood flour PLA, it's not possible to say that moisture equilibrium content has been achieved because the curve has not flattened yet. So this means that the material needs to be continue under conditioning with moisture to later on be able to achieve moisture equilibrium content. About the other conditioning, freeze-thaw cycling, it was the one selected was following the 7031 ASTM standard for wood plastic composites. Each cycle goes through 3 states. The first is moisture, then freezing, and then thawing. This was already completed also for wood flour PLA, so the next step is to test the specimens. The work to come for this research work is specimen preparation for all materials. So it needs to be done for wood flour aPLA and for carbon fiber reinforced ABS. Condition the materials, test the materials, and the following data analysis. After all of this is achieved, durability assessment needs to be done also. So then we will be able to know how durable this material is, who behaved better, and to be able to highlight the major differences in this research work. And this is the end of my presentation. Thank you.